Hello everyone, my name is Komatsu. I'm a lecturer in THAI-NICHI International College, and I'm originally from Japan, and I had worked for National Institute of Technology Kosen, Japan, for 8 years. And also I had worked for Japanese government space agencies, JAXA, for more than 30 years. I was a space engineer and designed International Space Station electric power systems. The space station had a solar power system, big one, and we had the same system on the ground. So, what is the solar power systems? In recent years, microgrid and smart grid that make effective use of renewable energies have been attracting attentions. Microgrid can utilize locally generated renewable energy such as solar power and wind powers, which have the advantage of providing stable supply of power even in emergencies. In this topic, you learn the basic of solar power systems. In these topics, we assume a simplified configuration of solar power systems functions, define the operating mode and the functions of solar power systems, and confirm the actual functions through laboratory simulations. During the daytime, electrical power generated by solar panels from the sunlight is converted from DC to ACs and distributed to the load. At the same time, surplus power flow into the batteries. At night, the solar panel can no longer generate power, so the load is supplied with power from the batteries. As a result, the voltage of battery gradually drops. In order to ensure a continuous uninterrupted power supply during the daytime and at the night, charge controllers constantly monitor the power generated by the solar panel and the power supplied from the batteries and control which power is supplied from which. On sunny days, amount of sunlight as shown in this graph, the solar power system supplies the power from the batteries from night to dawn and supplies power from the solar panels from morning to evening and then switch to the battery from the evening to night. The amount of power generated by solar power generation is constantly changing due to changes in the weather, and the amount of power supplied also changes due to the change in the power usage on the load side. Therefore, it is necessary to always supply the optimal and maximum the amount of power. The method always tracking maximum power is called maximum power point tracking, MPPT. This method is ideal for both powering home on the Earth and the power system on the space stations. Now let's simulate a solar power generation system using the basic component on the laboratory desk. In the laboratory, a DC power supply unit is used as a solar power simulator instead of solar panels. An MPPT type charge control is used to monitor and control the voltages and power. DC AC converters convert direct current to alternate current. A battery used for nighttime operation or when the voltage drop, and stand lamp is used as a load, which is the power supplies. Now let's start the simulations. gradually increase the voltage on DC power supply without the battery connected. The light will come on when the voltage reaches around 12.8 volts. So the light will come on if there is enough power available without the batteries. So next, gradually decrease the voltages until it stops supplying the powers at around 11 voltages. So next, decrease the voltages to zero voltages. And connect the batteries. So the power then starts being supplied from the batteries. This is the night mode operation until the battery, using the batteries. So at this time, you can observe the battery voltage gradually decrease and decrease. So next, let's simulate changing from night mode to dawn mode. Gradually increase the DC power voltages. So at this time, keep an eye on this current, the current value of DC power supply here, and input current voltage on the DC AC converters, DC AC converters. So currently about 1.43 the amperes of current is flowing to the load, the lamp, because the voltage of DC power supply is low. So almost no current is floating from the DC power supplies. So as we gradually increase the voltages, so you can see the current here on the DC power supply side increasing and increasing. So finally, the current about 1.40 amps flowed on the DC power supply, and the power supply was transferred from battery to the DC power supplies. This is transferred to the night mode to dawn mode. as the night turned into the morning and sunlight increased, I was able to see the moment when the role of the power supply was replaced by solar panels, solar power from the batteries. So let's try increase the voltage a little bit more. Increase also the current. The near by 2 amps. However, the lamp current here remains constant at 1.37 amps. The surplus, this surplus, the current is actually being used for charging the batteries. This graph shows the power data obtained from a simulation of transition from night mode to daytime mode. This graph also shows the power data when transitioning from battery operation to the solar power mode. So in this topic, we conducted a simulation on the laboratory and learned the basic of solar power systems. So in actually solar power system, the generated power changes depending on the time, weather, season, region, etc. And the power consumption on the load side is also changes constantly. So what can be done to ensure the stable operations? I hope you'll be thinking about this as well.
対日インターナショナルカレッジ Learning in a beautiful way